So here let's do an example where we want to find equation of tangent lines. So here find the tangent lines to the parametric equations given by x equals t to the fifth minus 4t cubed and y equals t squared at the point 0, 4. So basically, I don't know what this graph looks like, but if we were kind of to look at it, we're saying that 0, 4 is somewhere here. And this graph, kind of whatever that may look like, I don't know, maybe it looks like that. Okay. You have this parametric equation. Okay. If I were to graph it, plug in points, you get this. What I basically want to figure out is the equation of the tangent lines. So sometimes you might have one line. Sometimes you might have multiple lines depending on what the curve kind of looks like. So you want to be able to look at all those different types of lines. So that's basically what we're going to find, the equation of this tangent line. And remember that the way that we do it is with y equals mx plus b. Or another way to do it is a point slope formula, y minus y1 equals m minus x1. Okay, or m in this case is the slope. So let's do this problem, because I digressed. So we want to find the equations of the tangent lines. So remember, when we find a tangent line, you always want to find the first derivative. So we're going to start off with the first derivative, try to figure out what dy over dx is. We know that that's going to be dy over dt divided by dx over dt. So dy over dt is just this top part, that's just equal to 2t divided by the derivative of x with respect to t, that's just going to be 5t to the fourth minus 12t squared. Okay, so you can obviously simplify it a little bit if you really want to. What we're going to do, actually let me do that. So this would be 2 over 5t cubed minus 12t. Okay. All right, so now this is basically our slope, and usually when we would find the equation of a line, we would have to plug in a value here. Now we have x and y, the point x and y. We don't have t, so we need to figure out what is the value of t at this particular point. So at 0, 4, what we know is that x is equal to t to the fifth minus 4t cubed, and we know that y equals t squared. Okay, so let's try to figure out what t should be at this particular point. So x is 0, y is 4. I'm going to plug in 0 is equal to t to the fifth minus 4t cubed, and let's solve for t. Okay, so what we can do is we can take out a 3t cubed, t squared minus 4. This guy's just equal to t cubed, t minus 2, t plus 2 by factoring. So you see that t equals 0, t equals 2, and t equals negative 2. Okay? So basically, in order for this to match up, I need to make sure that the solutions to both of these equations are the same. Okay? So y in this case was 4, so I'm going to plug in 4. Let's take the square root to both sides, so t is equal to plus or minus 2. So notice that the only one that matched were these guys. The t equals 0 is not it. Okay? And also you can even check that t equals 0, if you plug it in, you get undefined. Okay? But that wouldn't be the tangent line. Okay? So now all you have to figure out is what exactly your tangent line is going to be. Now notice it says tangent lines, and that so you're going to have two of them because you have a line when t equals 2 and when t equals negative 2. Okay, so let's start off by our derivative. Our derivative was dy over dx was 2 over 5t cubed minus 12t. We're going to start off with t equals 2. So when t equals 2, your slope is going to be 2 over 5 times 2 cubed minus 12 times 2. And then when I do that, I'm going to get 1 over 8. And then I'm going to do it when t equals negative 2. dy over dx equals 2 over 5 times negative 2 cubed minus 12 times negative 2. Okay, and this is going to give me negative 1/8. Okay, so this is a slope. So the first one is going to be with the slope of positive 1/8. The next one's going to be a slope with negative 1/8. So you're going to have y minus y1 equals m times x minus x1. So we're going to have y minus y1. The point here was 4. M is 1/8. X minus x1 is going to be 0. So you're going to be left with y is equal to 1/8 x plus 4. And then you're going to do the same thing, but now with a negative slope. Use y minus y1 equals m times x minus x1. y1 is 4. M is just negative 1/8. X minus 0. So you're going to be left with y is equal to negative 1/8 x plus 4. So here are my equations of tangent lines. Okay, so now let's do another one. Find the equations of the tangent lines by the given parametric curves. So we have x equals t squared, and we have y is equal to t cubed minus 3t at the point 3, 0. Okay, so you can kind of pause the video if you want to try it out, or you can just do it with me. So we're going to start off by taking the derivative, because finding the tangent lines means that you have to find the derivative. Okay, so we're going to have dy over dx is equal to dy over dt divided by dx over dt. So dy over dt is just going to be this 3t squared minus 3 divided by 2t. Okay, again, you can simplify it if you really want to. Yeah, let's go ahead and do it. It'll be 3 over 2t minus 3 over 2t. Okay, doesn't really matter. It'll still give you the same answer. So this is going to be the equation of the slope, okay, for our slope. Notice again that we don't have a value of t at this point, so we have to figure it out. So at point 3, 0, we have x equals t squared, and we have y equals t cubed minus 3t. So let's plug in. So remember, this is our x and our y. So our x is going to be 3 equals t squared. Take the square root to both sides. So t equals plus or minus square root of 3. Y in this case is equal to 0. We're going to factor this out. You see that you get t equals 0 and t squared minus 3 equals 0. You see that t is also equal to plus or minus square root of 3. So you can see that these two are the only ones that match up. This guy is a no. Okay, so now what we got to figure out is find my slope. So we know that we have two values of t. T equals square root of 3. That's my first one. And the other one is t equals negative square root of 3. So now let's find our slope. So we know that dy over dx is going to be equal to, what did we say? 3/2 t minus 3 over 2t. Let's plug in the square root of 3. Okay, so what I would actually suggest is put this in the calculator if you don't want to rationalize. And if you do that, you're going to get square root of 3. I'm going to do the same thing with this negative. So dy over dx is equal to 3/2 t, which is going to be negative square root of 3, minus 3 over 2 negative square root of 3. Put this into your calculator, and you're going to get negative square root of 3. Okay, so that's the slope. So you have two different slopes. Okay, so now let's do it. So when the slope is equal to square root of 3, and also when the slope is equal to negative square root of 3. Okay, so let's plug them in to our equation. So we know that our point was 3, 0. Y minus y1 equals m times x minus x1. So y minus y1 in this case is 0. equals square root of 3, x minus x1, in this case it's going to be 3. So you're going to have y is equal to square root of 3x minus 3 square root of 3. And then my other one, y minus y1 equals m times x minus x1. Do the same thing. So this is still 0. This is negative square root of 3, x minus 3. So you're going to have y is equal to negative square root of 3x plus 3 square root of 3. So here are my two equations of tangent lines. Okay, and now let's actually do one last thing. Okay, let's ask one more question regarding this problem. For what points is the tangent line, or is a tangent, horizontal and vertical? Okay, so let's try to figure out what points is a tangent, horizontal and vertical. Well, if we were to look at the graph, so any type of graph, the tangent is horizontal like this, right? This is when the derivative is equal to 0. And the graph is horizontal whenever it's undefined. So basically, if you're ever asked for a horizontal, all you want to do is take the derivative and set it equal to 0. If you want to find for the vertical tangent, all you got to do is take the denominator of derivative and set that equal to 0. That's when it's going to be undefined. So if we look at our previous problem, we know that the derivative dy over dx is equal to 3t squared minus 3 over 2t, I think. Right? Yeah, this guy. Okay, it was just equal to that. Okay, you could have also used this one if you really wanted to. Doesn't really matter. Okay, but I think this one might be a little bit easier to do. So, so we have this guy. And now what we want to do is find the horizontal. So if you want to find the horizontal, well, one thing that you can do is just set the derivative equal to 0. Okay, so take 3t squared minus 3 over 2t equals 0. Notice the bottom part doesn't do anything. So we're left with 3t squared minus 3 equals 0. Then I add the 3. I'm going to get 3t squared equals 3. T squared equals 1. So t equals plus or minus 1. Okay. So notice that this is t. We want to find the points x and y. Well, we know that x is equal to t squared, and we know that y is equal to t cubed minus 3t. So all we got to do is plug in these points. So let's plug in t equals 1. So you get x equals 1 here. And when you plug in 1 here, 1 cubed minus 3 times 1, we're going to get negative 2. So the first point when it's horizontal is at 1 comma negative 2. And my next point is when it's t equals negative 1. Well, here x is equal to negative 1 in there, so it's going to be 1. Because it's 1 negative 1 squared, which gives me positive 1. And then we're going to plug in negative 1 in here. Negative 1. Okay, so this is going to give me a negative 1 plus 4 plus 3, which is going to give me just a 2. So it's going to be 1 comma 2. Okay, so these are the points where it's horizontal. Okay, now when it's vertical, all we're looking at is when the denominator is equal to 0. Notice that here the denominator is 2t. So here t is equal to 0. Okay, so just 1 point. So we plug them back into our parametric equations. You can see that x equals 0 and y is also equal to 0. So at 0, 0, it is a vertical. Okay, So these problems can take not too long of a time. You just have to make sure that you plug a lot of stuff in. Um, Notice that I could have easily also used, where did it go? I could have used this one to solve for my vertical and horizontal tangents. You can also see here the denominator is 0, so you would have gotten it. If you would have set this equal to 0, you would have added it to the other side and cross-multiplied and still would have gotten the same answer. So either of these, it doesn't really matter. It's a matter of preference. So I would always just maybe have the more simplified version there, depending on the problem. But you can either, it really is up to you.